Imagine a world where the blind can see again. Can a virus be the key to unlocking this seemingly impossible feat? Now that's a question that might seem straight out of a science fiction novel. But with the rapid advancements in biotechnology, it's a question that's becoming increasingly relevant and exciting. You see, viruses are typically associated with disease and illness. But what if we could harness their power for good? What if we could use them as a vehicle to deliver therapeutic genes into the human body, specifically targeting cells in the eyes? The potential implications are staggering. We could revolutionize the way we treat blindness and vision loss, creating a world where sight is no longer a privilege but a right accessible to all. It's a bold vision, isn't it? But it's a vision that's rooted in scientific possibility. Now let's delve into the science that could turn this fantasy into reality. Viruses, often seen as foes, might just be the unsung heroes in our fight against blindness. Now this statement might sound counterintuitive. After all, viruses are known for causing diseases, not curing them. But when we delve deeper into the world of virology, we find that these microscopic entities have a few tricks up their sleeves that we can harness for our benefit. To understand this, let's take a quick detour into what viruses are and how they work. Viruses are essentially tiny packets of genetic material, either DNA or RNA, encased in a protein shell. They're not alive in the conventional sense, as they cannot reproduce on their own. Instead, they hijack the machinery of living cells, injecting their genetic material into these cells and tricking them into making more viruses. Now here's the interesting part. What if, instead of carrying harmful genetic material, a virus carried a beneficial gene? Imagine if a virus could deliver a functioning gene to a cell that has a faulty one causing disease. This, in essence, is the concept of gene therapy, using viruses as molecular couriers to deliver therapeutic genes where they are needed. So, how does this relate to curing blindness? Well, many forms of blindness are caused by genetic defects that affect the cells of the eye. If we could use a virus to deliver a healthy version of the faulty gene to these cells, we could potentially restore their function and cure the blindness. In the realm of medical science, this is more than just a theory. It's a burgeoning field of research with promising results in preclinical and clinical trials. Scientists are working on modifying viruses to make them safe for use in humans, ensuring they can deliver their genetic cargo without causing disease. With this understanding of viruses, we can see how they could potentially play a role in curing blindness. Imagine a world where a microscopic entity, once feared as a pathogen, becomes a beacon of hope for those living in darkness. The irony is as beautiful as it is profound. To see how a virus might restore sight, we first need to understand how our eyes work. The human eye, a marvel of biological engineering, is much like a camera. Light enters through the cornea, the clear front surface of the eye, and passes through the pupil, the dark circular opening in the center. The size of the pupil is controlled by the iris, the colored part of the eye, which adjusts to regulate the amount of light that enters. The light then travels through the lens, which focuses the light onto the retina at the back of the eye. The retina is lined with millions of photoreceptor cells, namely rods, which help us see in low light, and cones, which allow us to see colors. These cells convert light into electrical signals that are then transmitted to the brain through the optic nerve. Now here's where it gets interesting. Some people are born with genetic mutations that cause these photoreceptor cells to malfunction or die, leading to vision loss or even complete blindness. Conditions such as retinitis pigmentosa and macular degeneration are examples of such genetically driven visual impairments. Imagine if we could replace the faulty genes causing these conditions with healthy ones. This is where the concept of gene therapy comes into play. It's a method that uses viruses, nature's own genetic engineers, to deliver healthy copies of genes into cells. But wait, viruses? Aren't they the bad guys? Well, not always. Some viruses can be modified so they can't cause disease, but can still deliver genetic material into cells. It's like reprogramming a villain to become a superhero. This method has the potential to replace defective genes in the eye's cells, thus restoring or at least stopping the progression of vision loss. Now that we understand the eye's mechanics, let's look at how a virus could potentially fix these issues. Enter gene therapy, where viruses could potentially help restore sight. To understand how viruses can be our allies in this quest, we first need to understand what gene therapy is. Simply put, gene therapy is a technique that uses genes to treat or prevent disease. This approach allows doctors to treat a disorder by inserting a gene into a patient's cells instead of using drugs or surgery. Now you might be wondering, how do we get these genes into cells? Well, that's where our viral friends come into play. Viruses are experts at getting into cells. It's what they do best. In gene therapy, scientists take advantage of this ability. They use viruses as delivery trucks, carrying the therapeutic genes into cells. But don't worry, these aren't the same viruses that give you a cold or the flu. The viruses used in gene therapy have been modified in the lab so they can't cause disease. They're stripped of their harmful components and engineered to carry therapeutic genes instead. Here's how it works. Scientists start by identifying the faulty gene that's causing the disease. Then they find a healthy version of that gene and insert it into the virus. This modified virus, or vector, is then introduced into the patient's body. The vector travels to the target cells where it delivers the healthy gene. This new gene takes over the function of the faulty one, potentially curing the disease. The beauty of gene therapy is that it addresses the root cause of the disease rather than treating the symptoms. In the case of genetic forms of blindness, the problem usually lies in the retina, the light-sensitive tissue at the back of the eye. Certain genes are essential for the normal function of the retina. If one of these genes is faulty, it can lead to blindness. Gene therapy offers a way to fix these faulty genes. It can deliver a healthy copy of the gene to the retina, potentially restoring normal function and curing the blindness. The first successful clinical trials of this approach were carried out in the early 2000s. Since then, the field has seen rapid progress, with several gene therapy treatments now approved for use. But it's not all smooth sailing. Gene therapy faces several challenges. One of the biggest is getting the vectors to the right cells without causing side effects. Another is ensuring that the new gene functions properly once it's in place. Despite these challenges, the potential of gene therapy is enormous. It offers a ray of hope for those living with genetic forms of blindness. And it's not just about sight. Gene therapy could potentially treat a wide range of diseases, from cancer to heart disease to neurological disorders. Scientists all over the world are working tirelessly, pushing the boundaries of what's possible with gene therapy. And with every passing day, we get closer to turning the promise of gene therapy into reality. With this powerful tool, we may be on the brink of a breakthrough in curing blindness. We've explored an exciting possibility today, the potential of a virus to eradicate blindness. Imagine the world where the word blindness becomes obsolete, a thing of the past, a historical ailment. This is not a far-fetched dream anymore. By harnessing the power of viruses, we are on the brink of a medical revolution that could change lives forever. Let's recap our journey so far. We delved into the world of viruses, these minute life forms that have been a part of our biological history for millions of years. Viruses, despite their negative reputation, are incredibly efficient at what they do. They can infiltrate host cells and manipulate their genetic material. It's this unique ability that scientists are keen to exploit for the greater good. We then journeyed into the intricate science of sight. We learned about the complex systems at work every time we open our eyes. The retina, the optic nerve, the brain, all working in harmony to convert light into images. But what happens when this system fails? Blindness occurs. But here's where our journey takes a hopeful turn. Enter gene therapy. By using viruses as vectors, scientists can deliver corrective genes to malfunctioning cells in the eye. This can potentially restore sight in people with inherited retinal diseases. The beauty of this approach is its targeted nature. The virus can deliver the therapeutic genes to the exact location where they're needed, reducing potential side effects. Of course, there are challenges ahead. The road to a cure is never straightforward, but every step forward is a step closer to a world where blindness is a thing of the past. We've seen the potential of a virus, not as a villain but as a hero. We've seen the intricate workings of our vision and the hope that gene therapy brings. And while the journey is far from over, there's a promising light at the end of this tunnel. While we're still in the early stages, the future looks bright for those suffering from blindness, all thanks to the unlikely hero, the virus.